So remember on Friday, no, I'm going to go back to it in a second. Remember on Friday, we were solving systems of equations by using matrices. And with that, our goal was to have something where you had ones on the diagonal, zeros everywhere else, and then equals numbers over here. And so then, if you have it set up like that, when you read it, it's x equals this number, y equals that number, z equals this number. So it gives us our solution. Now, we talked about, like, this method seems a lot longer for two equations, and it is. But if I were to put 4 or 5 equations, elimination becomes extremely long and complicated, and this becomes the easier method. So we're not starting with 5 equations to learn it, but that is the place. It has a reason, so don't complain to me that it's so much longer than the others, because there is a time and place when you would need it. Now, when you go through this, we have to solve it a very specific way, because if you don't go in the right order, then you will end up undoing the work that you've already done. So we go column by column. So we start in the first column. First you get your ones, and then you get your zeros. So then once the first column's ready, you go to the second column. You get your 1 in row 2, column 2, then you get everything else as a 0. You move to column 3, get a 1 in row 3, column 3, everything else in the column 2 is 0, and proceed using that method. So we've only done one problem where we actually worked through the entire thing. So we're working with those today. Remember, the legal things we can do. So it's just like substitution or really just like elimination. It is legal to swap rows. You know, if I'm looking and my second row has a 1 for the first number, I could move that to the top because it doesn't matter which equation's on top, so we can swap rows. We can multiply rows by anything except 0, and we can add them together, just like in elimination. You decide what you want to cancel, and you take each row times something and add them together. So we can multiply and we can add them together. So let's look at this system. All right, so first you have to write the matrix. What's my first matrix? Or my first one? 1, 1. We do a vertical bar for equals, and then 8. And the second row?
1 minus 2.
So, first thing, we need a 1 in row 1, column 1. And we've got it. So then, we need everything else in this column to be a 0. When you get that 0, you have to describe to me what you're doing. So you have to write your row operation. Which row are we changing? Okay, so we're going to do row 2. All right. What would you do to row 2? Okay, subtract. So could you do row 2 minus row 1? Right. So we're changing row 2. So row 1 stays the same. Okay, row 2, you're going through each number and subtracting the number in row 1. So it'll be 1 minus 1, which is 0. Negative 1 minus 1. 4 minus 8. Okay, so column 1 is good. Then you go to column 2, and you need a 1 in row 2, column 2. So what always works to get a 1? Reciprocal. So I'm changing row 2 again, and all I need to do is multiply by the reciprocal. So that's just negative 1/2 times row 2. So, R1 didn't change. row 2, 0 times negative 1/2 is still 0. Negative 2 times negative 1/2 is positive 1. And negative 4 times negative 1/2 is positive 2. It is a Monday. We don't have too many left. All right, am I done? No. We need this number to be a 0. So I am changing the row 1 equals, what would you do to get that to be a 0? Okay, subtract row 2. What would happen if you did row 2 minus row 1? This 1 would turn into a negative 1. So you would have to then fix that again. So, row 2 didn't change. So row 1 minus row 2. So 1 minus 0 is 1. 1 minus 1 is 0. And 8 minus 2 is 6. So our answer, we get x equals 6 and y equals 2. So the word there, 6. Is that one okay? Let's do another one. So first, set up the matrix. So the first row would be negative 1, 4 equals 0. Second row, 2, negative 4, and 6. What do we need first? Need that to be a 1. How could I get that to be a positive 1? So I'm changing row 1, so row 1 equals, and you said just multiply it by a negative 1. So negative 1 times negative 1 is positive 1. 4 times negative 1, negative 4, and 0 times negative 1 is 0. What next?
Do 0 and row 2 column.
So we're changing row 2. Okay, there's 2 different ways we can get that to be a 0. So you could multiply this row by a half and subtract the other one, or if you think about elimination, what would you do? If your equation was like x and then this was a 2x, what would you probably do? Take first one times the negative 2 and then add them together. So both options work. So it is completely up to you. Which one do you guys want to do?
It's hard to hear.
The first,
Okay, so
I don't even know what you're talking about.
I don't understand what you're saying on the second one.
Oh, I was just avoiding the fraction. So you said take this times the
Yeah,
half.
do the other one while you're using a fraction.
Because it's all even, so it'll like cancel out. It'll be fine.
So if you take that times a half, can we do it just a negative 1/2, and then we can just add the first row to it? Okay. So you guys are saying we are leaving the first row alone. All right, to get the number in the second row, you're doing negative 1/2 times the number in this row plus the number in row 1. So negative 1/2 times 2 is negative 1 plus 1 is 0. Okay, same thing all the way through. So negative 1/2 times negative 4
2.
plus negative 4 is negative 1/2 times 6 plus 0. All right. So column 1 is good. Now what do we need?
Row 2, column 2, 0, 1.
So get our 1 in the column first, and then we'll get our zeros. So how could I turn, we're changing row 2, how could I turn that negative 2 into a 1? Yeah, you could just, probably the easiest way to get a 1 is just to multiply by the reciprocal. So reciprocal of negative 2 would be negative 1/2. Okay, so 0 times negative 1/2 is still 0. Negative 2 times negative 1/2 is positive 1. And negative 3 times negative 1/2 is 3/2. Okay, we're almost there. We got our 1, so now we need this to be a 0. So what row am I changing? Okay. What would I do? Well, let's just start with this. If we just start with row 1, it's a negative 4. What do you have to add to negative 4 to get a 0? 4. So we're going to add 4 of row 2. So we're going to take second row times 4 and add them together. So we have 1 plus 4 times 0, which is still 1. Negative 4 plus 4 times 1. And 0 plus 4 times 3/2. So what's my answer?
6 and
X equals 6. Y equals 3/2. Another one.
Where's Gage? How you missing Gage? Anybody see him? Will I FaceTime him right quick?
Or doing this by ourselves?
Oh, we'll do it together. Just give me a second to write it down.
I'm not gonna lie, it's something like, it's just like beyond me.
Yeah.
Don't complain. We're taking it slow. There is a reason. Just be patient.
I'm not complaining. It's not clicking yet.
Yeah, it's totally new. That's why you didn't have any homework Friday, and we're still
And
just
homework
practicing the
today,
same
so
thing
like-
over and over and over again.
It's hard, I haven't done homework today too.
So what's the first row?
1 plus 1, 1, 2.
1, 1, 3.
And the second row?
2, 2, 5.
Okay. So what do we need first? Everybody should be able to answer this
Zero.
question.
One.
A 1 in row 1, column 1. But we have it, so what are we going to get
Zero.
first?
Like I
The
said.
0. Because we're getting the first column first. Okay. So we're changing row 2. Think about elimination, guys. If I gave you these original equations and I said eliminate the x, what would you do?
Put negative two on top.
Take the first one times -2 and add it, right? So that's what we're going to do. We're going to do -2 times the first row and add it to the second row. All right. So first row stays the same. So second row. -2 times 1 plus 2.
I like the way she did it.
What? So -2
I tried going on by myself.
Oh.
It would be 0.
times the first plus the second. So -2 plus 2 equals.
Whoa, wait. If the two zeros, then there's no y, so it's inconsistent.
So then
It should be the x, y. arbitrary.
-2 times 2 plus 5.
One.
Okay. What does that bottom equation say?
0 equals 1.
It says 0 equals 1. Does 0 equal 1?
No.
No. So what does this mean?
No solution is consistent.
No, that's gonna be like that one.
What if it were 0 equals 0? Is that possible?
Yes.
It'd be like the arbitrary thing.
Yes. Then you would write it with a variable arbitrary. Good.
I don't even want to dabble in
Right, right.
Right, you have golf today?
Let's
No,
do
no,
another.
we got tomorrow? Do we host like every day we meet?
No, how it was.
Okay.
It's not. It's like an island dream that we found.
Wow. Can we go back to the first one? Well, not the first one, the last one, where the X was already one.
Oh. Well, this is almost as done.
Can we split that?
So your first row,
I'm flipping it.
you could go ahead, if you recognize it when you go to write down your matrix, you could go ahead and just flip it and make your first row 1. Or if you wrote it down and then caught it, you could just say, okay, I want to flip those. So I'm just going to say row 1 equals row 2. And I'm going to flip those. That way we already have the 1.
Why don't you just do it? Just do it.
Otherwise, how would you turn that 3 into a 1?
I don't know.
Multiply by 1/3. To get a 1, you can always just multiply by the reciprocal.
But then you just do R1 plus R2, or R2 equals R1 plus R2 to get a 0.
If you multiply by 1/3, it would change that.
I'm talking about you get a 0.
Yeah.
But if you just flip it.
So we have a 3 here. We need that to be a 0. So we're changing row 2.
Would be -3 or
Uh-huh.
plus
So -3 times the first plus the second. And it doesn't matter what order you write that. If you put R2 minus 3R1, it's the same thing.
2. Wait,
I do the fraction one every time. Man.
Oh, well, you can multiply it. You could do like -1/3 row 2 plus row 1.
No, it's fine.
That's why you have to write down what you're doing because there are so many different ways to do it. Okay. So -3 times the number in the first row plus the number in the second row. Get 0. -3 times 2
me.
plus -2 gives us
Fraction.
and -3
What's shot?
times 6 plus 2.
Hey. Oh.
Negative 18
tripping.
plus negative 16.
Ooh.
What the heck?
Oh, because I'm.
You flip your first and second row.
Yeah, it's and then I. Yeah.
Wait. How do we get negative 12?
I see it now.
What's 6 times 3? 18 plus 2?
Oh my god.
Negative
Oh, never mind.
You
See,
write
when
it down wrong?
When I switched, I just kept them both 6s.
Oh, both of
Oh, there's only 3.
What do we need next?
Just one.
Oh.
Yeah, one.
Okay.
multiply by 8.
So to get a negative 8 into a 1, what do we multiply by?
One negative.
Negative 1. Just the reciprocal.
I don't even like asking one. I just go with the flow.
So 0 times negative 1 8 is 0. Negative 8 times negative 1 8 is positive 1. Negative 16 times negative 1 8. Yes, sir.
Okay. I have negative. No, it's not. 4.
Oh. Now what do we need?
Zero on the top.
Negative 2 R2 plus 1.
So we're changing the first row. If you think about elimination, you would have to take the second row times negative 2 and then add it to the first.
Always be doing it right. No fraction. No fraction. Two fractions. No fraction.
So negative 2 times 0 plus 1. So negative 2 times 1 plus 2. Negative 2 times 2 plus 6. So
She had something different.
x equals 2 and y equals 2. Does it matter which one I put on top here?
No.
No, neither one has a 1 in that position, so it's not going to save me time by putting one on top versus the other. So all right. To get a 1, you can do the same thing every single time, which is what? Multiply by the reciprocal. So row 2 stayed the same. So 2 times a half is 1. Negative 3 times a half. Negative 3 halves. Negative 7 times a half. Negative 7 over 2. And you're welcome to use a calculator if you get to a point when we're adding and subtracting with these fractions. If that confuses you, you have a calculator, so don't get hung up on that. What do I need next? A 0 right here. Okay, the easiest way to get a 0. So which row am I changing? All right, you always get the zeros after you get a 1, right? So let's look. Row 1 has a 1 here. So the easiest way to get a 0 would just be to take my first row times
Negative 5.
negative 5 and add them together. Okay. So again, you can use a calculator if you have to. We're not changing the first. We will get some fractions here. negative 5 times 1 plus 5 is 0. Negative 5 times negative 3 halves plus 4. Get 23 over 2.
Yes.
Negative 5 times negative 7 halves plus 17.
Yeah, one. Pretty easily.
Okay. Well, where are you lost?
I don't even know. I'm just copying you down now.
All right. So it looks a little bit ugly at the moment, which is possible. I mean, there's no rule with systems of equations that we have to get nice integer answers. We need what next? A 1 in row 2, column 2. So easiest way to get a 1 is multiplied by the reciprocal. So we're taking row 2, reciprocal, just flip that fraction, 22 over 23. So 0 times 2 over 23 is still 0. 2 over 23 times 23 over 2 is 1. 2 over 23 times 69 over 2. We are one step away. We need this to be 0. So, easiest way to get a 0. Which row are we changing? Okay. We just got a 1 right here. So what could I take this row times?
Positive 3 halves.
If you multiply it by 3 halves, then you could add the 2 together.
The part that messes with me is that it doesn't actually change. Like, the bottom row doesn't actually really change.
Right. Because we're only changing row 1. So we're doing 3 halves times row 2 and adding that to row 1. So row 2 stays the same. So row 1, we're doing 3 halves times the number in row 2 and adding that to row 1. So 3 halves times 0 plus 1 is 1. 3 halves times 1 plus negative 3 halves is 0. 3 halves times 3 plus negative 7 halves will be my answer. It says x equals 1, y equals 3. stopping for today. We are still working on this, okay? We don't have it done yet. If you look on Classroom, I posted a handout. The majority of those are not anything, not the full problems. The last two, you're actually solving the first couple. You're just doing a row transformation. Third one, you're just writing a matrix. So those are more like what we were doing on Friday. But I'm giving you time right now so you can work and ask more questions, okay? And we're going to keep practicing
This is
on
deadline